Steve, how long ago was it that you were here?
About 3 years, I think.
About 3 years. And one thing that I have noticed over these years is that the weather does change. But our guest speaker today is Steve Shiveley, who is a meteorologist at the National Weather Service office in Ruskin. Steve's going to celebrate 11 years this December. If he had been here in January, like we planned, it might have said only 10, but 11 years with the National Weather Service, and he spent part of his career as an on-air meteorologist with WGXA in Macon, Georgia, and WMDT in Salisbury, Maryland. Steve is also experienced with aviation operations and forecasting. He spent 4 years in the U.S. Air Force, stationed in Biloxi, Mississippi, and probably the hardest duty on the planet, Honolulu, Hawaii. Steve's a graduate of Embry-Riddle Aeronautical University with the Bachelor of Science in Applied Meteorology. He's also a member of the American Meteorological Society. Now, for those of you who did not know that we had an office of the National Weather Service that's close to us, Steve's going to tell you where it is. He's going to give you some basic weather knowledge, and perhaps we might even be able to twist his arm to find out how many hurricanes we still may see yet this year. So if you would please, help me welcome Steve Shiveley.
All right, well, good morning, everybody. Like I said, meteorologist Stephen Shiveley. Obviously, this is not a thunderstorm that you see in Florida. This is somewhere out in the Midwest, but just like to have it up there. I already had a great introduction. Normally, I kind of introduce myself a little bit, but pretty much already got it covered, so we can go right ahead from that one. So first, I just want to tell you kind of what we do at the National Weather Service, how we work, how we function. If you don't know, we do live very close to you. Our office is just in Ruskin, so it's just literally on the other side of the interstate from here. So it only took me about 5 minutes to drive here, which is always nice. But we have a much bigger area to cover than that, which we'll get to in a moment. But first, here's kind of our chain of command. So we got the President, Department of Commerce, and then NOAA, and then the National Weather Service. A lot of people are always interested why we're under the Department of Commerce. Well, you'll see here in a minute, one of our main mission is the preservation of life and property. I don't know why the thing wants to try to auto slide for me. I don't want it to. Let's see if I go back once, and then maybe it'll stop doing it. But that's probably why the property part of it. So you'll see that mission come up, but that's why we're under the Department of Commerce. There are so many parts of NOAA, you know, our branch of National Weather Service, but you can see there's so many other parts of it. We got the Marine Fisheries Department. So they're the stewards of the ocean. So if any of you guys are big fishermen and stuff, you know, some of these fish are in season, out of season. They end the season early, open the season late. It's NOAA that's regulating all that. And there's actually no facility not too far away either. Beautiful 3-story building right in St. Pete, right on the water there. I'm jealous of their facility. We have the National Oceanic Services, so they kind of collect all the tools, the devices, everything that they're measuring the ocean, taking stats on the fish and all that stuff that's going on in the ocean. The National Environmental Satellite Data and Information, so kind of the same thing, but they're more about space. So, you know, the satellites and all the stuff we have in space. And then we got the research branch, which kind of says for itself, they're doing all the research. You know, all that behind the scenes stuff. And what's interesting is NOAA's under all this stuff, and that's mainly focused on the ocean aspect of it. Well, the National Weather Service, we kind of have all of this within the National Weather Service. They're just not separate branches. We're kind of all combined when it comes to the weather aspect of things. But I know a lot of you guys are veterans here, so this is very interesting. NOAA actually has a uniform service. We all know, you know, Army, Navy, Space Force now, Coast Guard, Marines, Air Force. Well, NOAA actually has an official uniform service. It's managed by NOAA's Office of Marine and Aviation Operations. They manage a fleet of 15 research and survey ships and 9 specialized environmental data collection aircraft. So a lot of things they're doing is they're mapping the ocean, but they're also mapping things like the bay. You know, Tampa Bay is a very important aspect to us, especially if you're going on your cruise ships, but a lot of the products coming in is going through Port of Tampa. And it's like after Milton and Helene, when we got all the damage, all of the storm surge and all that stuff, it changes the floor, you know, and it changes how those channels work. And it was NOAA that came in with their ships that did the sonar, their aircrafts that came overhead and did all that surveying so we could know when to open the port again. So they're a very important aspect of our job. But yeah, just really something interesting that I didn't really know about until I got to the National Weather Service, that you could actually have a uniform NOAA services. If you're wondering, they go through, I believe, the same boot camp and instruction as the Coast Guard does. They kind of go through that training first, and they kind of branch off and start doing their own training after they go through boot camp and stuff. So now let's talk about the National Weather Service. We kind of talked about the other parts of NOAA real quick. So like I said, our mission is to provide weather, hydrology, and climate forecasts and warnings for the United States, its territories, adjacent waters, and ocean areas for the protection of life and property. So like I said, that "and property" is why we under the Department of Commerce, and the enhancement of the nation's economy. I'm sure you've seen it before. This disaster, cost, $1 billion or $100 million, and this and that. That's that economy aspect of it. And they can calculate, well, if we weren't here, how much more would it have cost? And stuff like that. So that's why we're here. So our most important mission, though, is really the people. That's what we care about the most, keeping you guys safe and protected. There is 123 now National Weather Service across the whole nation. So you can see them kind of split up there. There's a lot of us. And, technology now is amazing. We all know this. I could be sitting in Tampa, and I could easily forecast for California, Alaska, Hawaii. When I was in the military in Hickam, I was actually forecasting for Korea and Japan on the other side of the Pacific. That is something we can do. We have the capability to do something like that. But research has shown that if you live where you forecast, you tend to forecast better. And if you're forecasting the same area day in and day out, you become better at it, obviously. So instead of us doing kind of the Weather Channel thing where, we're forecasting the whole country, maybe one day I'm in Florida, the next day I'm forecasting for Utah, the next day I'm up in Maine, I'm not getting that local weather knowledge. Some of y'all, I'm sure, have lived here 40, 50 years in Florida. You guys know how the weather works here just from doing that, just from that climate aspect of things. And the same thing with us. We have people in our office who have been in our office for 30 plus years. They know this area. They know how the weather works. They know the terrain. And also what's good too is we have those relationships with your emergency managers, with the people, with the men's club. You just contacted me again. Those relationships are important. We're here for you, and we're not going anywhere. I mean, yes, people do, transfer out and stuff, but for the most part, we're here. We have those deep relationships with the public and with the community, so that's very important to us. How they break this apart is very interesting. So it's about, yeah. Oh, there you go. It's about how active that area is, but it's also about the population. So you can see somewhere like Los Angeles, not too much weather, but a huge population. And then in the Midwest, where you see all these tiny offices, yeah, there's not a lot of population out there, but it's Tornado Alley. Very active weather, very busy. So that's how they kind of calculated all of it. All right. This is a closer view of what we cover. So everything in red are the counties we cover. So we cover from Levy down to Lee, and we cover, pretty much all through to Polk and Highlands County. So anything weather related in that area, watch, warnings, advisories, statements, it's our charge to do it. It's our charge to handle it. And most people don't know we actually cover up to 60 miles out in the Gulf too. So marine forecast, marines, stuff like that, we handle all that stuff too. So there's many times where a hurricane might not be directly impacting West Central Florida, but we got that Gulf out to 60 miles. So we might still be busy in the office forecasting for our marine partners, helping our marine partners out too. So pretty much if you see anything, even like small craft advisors, if you're boaters and stuff like that, we're issuing all that stuff from our office. And we cover a good portion of Florida. I'll go back. You can see there's Key West down there, Miami covers South Florida, Melbourne, Jacksonville, Tallahassee, and then Mobile technically covers those last two counties in the Panhandle. But in my opinion, we kind of got the short end here because we got pretty much the whole West Coast here. East Coast has got Jacksonville, Melbourne, and Miami covering a lot of the East Coast, and we kind of got most of the West Coast to ourselves. So the people, we have 26 people, 14 meteorologists when we're fully staffed, and we are 24/7, 365. So there's always at least 2 people in our office at any moment in time. Even on a gorgeous, beautiful day where there's no weather going on, there's still 2 of us there, forecasting, answering phone calls, getting ready for anything that might be coming up. If it's quiet days, just like any other job, we have training, other projects, getting ready for PowerPoints, for presentations, and all that kind of stuff. So We are doing other stuff too, and like I said, it's already up there, one of 123 offices. I keep on emphasizing 23 because they just added America Samoa like 6 months ago. So that's a new office. They were very excited about it, so I had to update all my slides and all my information to make sure to include that. So what do we do? So we do so many things. I find stuff that the National Weather Service does sometimes that I didn't know we do, like on the national level or the regional level. We do our basic 7-day forecast. So if you guys want to go to weather.gov instead of weather.com and put in your zip code, you'll get our forecast. We educate the public, exactly what I'm doing right now. The second most important thing is we work with your state and local governments to prepare for disasters. So I'm talking with you guys today. I've talked to your emergency managers. I've talked to, all those people that make those decisions about hurricane evacuations and, who needs to be prepared and what needs to be going on. When do those sandbags need to come out? The great thing about my job is I don't have to make those decisions. I don't want to make those decisions, but I provide the information to help out those decision makers as best as I can. Whatever they need to know, whatever they need to have information about, we are here to help them with that and help facilitate the information there's so much information out there about weather, help to kind of narrow it down for their specific needs. But of course, the most important thing of all we do is we issue the watches and warnings. The stuff you guys see on TV, the stuff that gets you guys prepared. That's the most important thing to do because that's how we're protecting you guys on a day-to-day basis. And I know it's silly, but I always like to go over what a watch and warning is. I do it with every presentation, no matter the age or who they are. So I always like to say it kind of like if you're baking. So if you're a baker, a watch kind of means we have all the ingredients. So you can have all the ingredients on the table, to make cupcakes, but that's not a cupcake. Those are just all the ingredients. And that's kind of what we say when you hear tornado watch or severe thunderstorm watch. We're saying all those ingredients are in the atmosphere. Are they all combined? No, they're not. But all the ingredients that we know make up severe weather, make up tornadoes, is kind of in the atmosphere. And when a warning happens, that means all those ingredients came together just right, and we might have a tornado or we have a severe thunderstorm. And I like the baking example too, because if you ever tried to bake, it's not easy. It's kind of more of a science, right? You put a little bit too much baking soda, a little too much sugar, bake it for a little too long or something like that. It doesn't come out quite right. And that's the challenge with us forecasting severe weather and tornadoes too. All those ingredients can be in the atmosphere at a time, but if they don't come together just right, if that mixture doesn't come together just right, it doesn't happen, which is a good thing. We're happy it doesn't happen, but that's kind of one of the challenges we have when we come to forecasting weather. All right, now that we got through all of that formality stuff about what we do and all that stuff, I will try to drop a little bit of weather knowledge on you, if you guys already don't know it. So let's talk about sea breeze thunderstorms. We're in the middle of that activity right now, right? In the middle of summer, sea breezes. Well, how does it work? We talk about it all the time. TV Mets talk about it all the time. So what happens, I'm sure you know, is water heats up slower and cools down slower than land does, okay? The Gulf in October, when we get the first couple of cold fronts, is still going to be 85 degrees for another few weeks afterwards. It takes a little bit longer for that water to cool off. That's why we can still get hurricanes in October, because even though we might have gotten a little bit cooler, the water is still very warm. And the same thing happens during our summer months. So the land starts heating up much quicker than the water does. We get what we call differential heating, or the temperature is different. And when that happens, we start getting those sea breezes. And you notice right there in the arrows, they start coming in on both coasts. They collide in the middle, you have the lift, and that's really the last ingredient we need. It's always unstable here. We always have tons of moisture, we know that. It's always nice and humid. And that last step is to really push all that stuff up into the atmosphere, get it lifted, and then you have the thunderstorm development. So really during the summer, most days it's not, if it's gonna rain, it's where. Where is that sea breeze gonna collide every day? That's always the big question for us. It's always the big challenge for us, is where are those sea breeze boundaries gonna collide? Where are we gonna get the thunderstorms day in and day out? Well, just like any good scientist, we did research, right? That's what we do. So we figured out that our upper level flow, or how the winds blow above us, not right at the surface, depending on where the high pressure, where those winds blow, we can kind of figure out where those sea breezes are gonna collide every day. It's kind of interesting. So you can see in this example, so we call them all regimes. We have 6 regimes to help us out. You know, when the high is to our north a little bit, we get that south to southeast flow. Well, that means the east coast sea breeze is stronger. So you imagine if not only do you have the sea breeze, you have just the regular wind above us also pushing east. So that pushes the storms or the winds across the state much quicker, while the west coast sea breeze can't go in as far, and that results in this. You see the yellows and the reds are all on our coast. So whenever we have a south to southeasterly mean wind or the flow of that wind, we tend to have storms on our coast more. Now, flip it. Now, if we have the strong winds on the west coast, I don't think I had a slide for that. I think it was just one, wasn't it? Oh, nope, there you go, yeah. So then we switch it, right? So now the winds are more west-southwest. So now we have the westerly flow. When we have the westerly flow, it flips. Now you see the storms are more inland and towards the east coast of Florida. So just a simple way we did research to help us figure out where those sea breezes collide day in and day out. I think maybe it was 3 or 4 years ago. We had a very, very dry summer. It really did not rain that much at all. And it was because we were stuck in this. We were stuck in that west-southwest flow every day, just constantly. And that's what we've been stuck in most this week, is that west-southwesterly flow. Don't know if you noticed, it's been very warm, even for Florida standards in the morning. You know, like I said, we're just a mile 2 away from you guys. The low this morning was 82. That's the coldest it got. And that's because we have the westerly winds. The water temperature is 89 degrees. It's bath water out there. And that wind's coming right off the water all night long and pushing towards us. So, you know, the atmosphere, it can't cool because we're getting this hot wind just constantly pushing on land. And whenever we get the westerly flow, we tend to have warmer temperatures, more humidity, and we're getting less rain. It's really the rain and the cloud and the convection in the afternoon that cools us down. It helps, you know, cool down the atmosphere. Without that, you get what we're seeing now. Heat advisories, you know, temperatures getting close to 100 degrees. I think yesterday Miami hit 100 degrees for the first time. Yeah, first time since like 1940s. I don't work in that office, so I don't remember the exact stats, but yeah, it was since the 1940s. So yeah, it's been hot the last few days, even by Florida standards. It's always hot here, but even for us, that's a little much. So now let's talk about hurricanes, right? We are in the middle of hurricane season. So just like anything else, we need ingredients for hurricanes to form. You need warm ocean temperatures, which if you've been in the Gulf lately, it's plenty warm. Winds coming together, kind of like those sea breeze boundaries. Essentially, we need some kind of storms, either coming off Africa or later on this season, they come off Mexico or South America. Those storms kind of coming off the coast. Then we need wind flow aloft to be very light. And I'll get to, that's a very important ingredient that we'll get to. It's called wind shear. I'm sure if you guys watch the news enough, they talked about it a lot during this hurricane season. So you kind of need very light winds aloft. Why is that? Well, hurricanes are kind of like a vacuum, okay? It's sucking air up and then pushing it out. And it just wants to continue to suck that air up. It wants that warm, hot air. It wants to take all of it. And that's why, interesting enough, like a day before a hurricane comes, you know why it feels so nice outside, really? It's not as hot, it's not as humid. Because the hurricane's a vacuum. It's sucking all the hot, warm air around it, and it wants it all to itself. And that's why there's always that phenomenon. People are like, man, that day before a hurricane, it's always so nice outside. It's because it's sucking it all up. And then you have that humid air rising, and then you have those light winds, like I said, kind of letting it to vacuum. So if it's tilted like this, it can't use it. It can't do that vacuum effect. It can't suck up that air as strong as and efficiently as it did before. So I'm sure you've heard during this hurricane season a lot about Nino. That's what's coming our way. So Nino is the warming of ocean currents all the way on the other coast. You see right there in that yellow. And when Nino forms, it brings fewer hurricanes to us. Why is that? Well, it increases the wind shear, or that upper level winds aloft. And like I said, we need lower winds aloft to produce hurricanes. So it's producing these very strong winds pushing across really the whole Gulf, the whole Atlantic, and it causes fewer hurricanes. That's why we haven't seen any. If you watch the news, I think there's like a 70% area like a week ago, and it was done. It couldn't even form. It just got destroyed. Now, once we get into later on in the season, we will have to watch out more for the Gulf. That kind of what worries me more is these October hurricanes tend to form more in the Gulf after all of this stuff kind of gets settled down. So we'll have to watch that later. But because of Nino, we're not expecting much hurricanes. So this is the Nino forecast. So it's kind of hard to read if you've never heard it before. But You see JJA, that's June, July, August, September. So like O and D is October, November, December. So it's a 3-month forecast. And you can see Nino in red, and yeah, it's about 100% chance of Nino for a while. We are normally not this confident. Normally we, as meteorologists, we hate to put 100% on things, because I tell you there's a 100% chance of rainy day, and then the one person's house doesn't get rained on, well, you said it was 100%, okay, 98% then, So we don't like doing it unless we are very, very close. Now, so like I said, Nino's around. It should prevent any hurricanes from forming. Like I mentioned, it only takes one. Our strongest hurricanes we've seen, Milton, and then the one in 1923 were October. So, for some reason, we tend to get our strongest hurricanes much later in the season than people think. Everybody talks about the peak of hurricane season is late August, early September. We're kind of in it now or getting into it. But really, I feel like for the West Coast, it's really more that October when it comes like the really strong ones that could impact us more. And so this is like a cool climate page which tells you where the main development region for hurricanes are each month. We're in August, so I just want to show us that most of that development region is out in the Lesser Antilles, and then sometimes you'll get a low pressure system come off the East Coast. But that's why during August, you'll see everyone talk about, the tropical waves or the thunderstorms off Africa, coming our way. Let's watch it. That's where Ian formed and Irma formed, whereas, off of there, then it went south of Cuba and did its little curve up move. So that's the main development region in August. That's when we're looking for that storm development. And I didn't add the other slide in there, but this changes a lot as we get in like October. As we get into like late September, early October, that development region starts turning south of Jamaica, Cayman Islands, Yucatan Peninsula, where Milton formed like right near the Yucatan Peninsula, remember? That's the main development region later on in the season. So that kind of shifts what we're looking at. We stop looking at the Atlantic, we stop looking at waves off Africa, and we start focusing more closer to home, which is more difficult for us. If we remember Ian from 6 or 7 years ago, I feel like we were talking about it for 2 weeks. It went through Puerto Rico, went through Cuba, Key West, and came up. We had a week or two, and then Milton came, and it felt like it was like this. Formed in the Yucatan, heading straight for us. We had maybe 3 or 4 days to get ready and get going, and that's not a lot of time when you're talking about a big populated area like Tampa to get everybody out and get people prepared. But Nino also affects our winter months. So yes, it is helping us out immensely during the summer, helping us keep the hurricanes at bay, keeping that away from us. But during the winter months, it actually gives us more active weather. So what it does is when Nino happens, it pushes the jet stream. If you ever heard of that, it's like the upper level wind flow. If you're ever flying on a plane and you get there 30 minutes before you're supposed to, it's because the jet stream was kind of helping you out a little bit. That jet stream pushes further south, and you can see that arrow there, and it makes us cooler and wetter. It brings a lot more active weather to us. Last year, we didn't have Nino in place, and yes, it was cold. It was the coldest winter we probably had in about a decade, but it wasn't wet. We didn't have severe weather with it. It was cold, but we didn't have that weather impact. Well, this year, I think we're going to. So you can see right here, this is like a Nina or like a, severe weather reports for the winter months. You see that's the kind of the red, dark red, but then you see that light blue purple color. That's the severe weather reports we see during a strong Nino, which is what we're going to be having. So you can see that really jumps up during the winter months. So that's something we're going to have to watch out for as we get later onto this season. As we get later into the winter months, expect it to be a little bit wetter, expect that activity to be, a little bit more robust than what we saw last year. Last year was cold, but we at least survived and we didn't have to worry about severe weather at the same time. That's really about it. I don't like to, kill you guys with a PowerPoint if I don't have to, but if you want to, I can take questions now. Or I don't know if everybody's hungry and would rather eat. That's fine too.
Take the questions. I think he's still getting set.
Okay, go ahead.
I was just wondering, since we're having the El Nino in October, would that help would that prevent formation in the Gulf hurricanes like you were talking about?
It should continue to help prevent them. I do worry because, during the summer months, it's very cut and dry. Nino, high wind shear Atlantic. But then you can start getting the Gulf in October. You might have a cold front come in or something, because that's what it likes to do. The lows like to form off like a tail end of a cold front. So, it makes the science a little bit more difficult. The dynamics are a little bit more muddy, I would call it. So that's why it worries me a little bit more. But that, something we'll have to watch out for. It should technically, though, stat-wise, hopefully keep it at bay. Here.
Yeah, how is AI entering into weather forecasting? It seems like it's right in the wheelhouse.
Yeah, that's an excellent question. So if I didn't hear, how's AI helping weather forecasts? That is a great question. So Google already made an AI weather model. It's called Google DeepMind, which is a very cool name. Google DeepMind outperformed every other model when it came to hurricane forecasting last year. And it was the first year they had it. Like they literally was like, here you go, let's see what it does. And it outperformed every other model we ever had. So it is helping, and people worry, okay, how about job security, how are we gonna do? Well, it kind of frees us up. If the forecast is good enough, we can come out and deal with the public more, help with emergency management more. We can be embedded with them more. We can help with that support aspect of it. And yes, it's getting good, but it's not gonna. Warning operations, we have like some technology, some AI that tries to predict like, oh, this cell's gonna produce a tornado, this cell's gonna produce severe thunderstorms, but that dynamic stuff like that, it's nowhere near that kind of stuff. So what I call nowcasting, or that 1 to 2 day forecast, it's not very good, but 4 to 7 days out, we can't beat it anymore. AI is here, it's killing us, forecasting wise. So we kind of let the models, for the most part, handle that. I mean, we know there's weaknesses, and we do end up still putting our hands in stuff, but yeah, it's definitely getting there. Oh, which one are we putting it? Okay. Oh, you got a mic, sorry.
If we're in a hurricane watch, who makes the call in terms of going into a warning?
Yeah, that's a great question. So who makes those decisions, the watch and warn, when we put those watch and warnings out? That is all up to your emergency managers and the government. So, the governor and stuff like that has to say, but it's really those emergency managers. They're the ones, we can give them all the information we can, but like I said, we can't make the decision for them. We can nudge them a little bit sometimes, say, are you sure? But it's ultimately up to those emergency managers. And the city and local government do have some say in it, but I will say most of the governments around here, which is a good thing, they kind of stay out of it. It's not up to the mayor to just, they're going to have other, priorities. They might want to wait, and so the emergency managers really have that decision making, which I would not want that choice, because it's a lose-lose. I feel like if you evacuate everybody and it doesn't happen, they get mad. But if you evacuate and things get destroyed, they're somehow still mad at you. It's a rough job to have, but it's theirs.
What degree of confidence is there in these 7 and 10 day forecasts, and what are they based on? And is the hope that 10 days from now we'll forget what you said?
Yeah, it all depends. The National Weather Service, we never go past. The National Weather Service, we never go past 7 days. We don't. It's too muddy out there afterwards, because how I try to describe it is, if you have a small error in day one, that small error gets bigger and bigger and bigger and bigger as time goes on. So 6-7 days out, we're not that accurate. I mean, we can see a front come and be like, okay, we know a weather system going to come in and rain, and is it going to be in the afternoon? Is it going to be maybe the night before? We don't know that, but we know something's going to come in and stuff like that. And things do, this front's going to come in, and we'll look at it, we're like, this is going to be bad 6 days out, and then it weakens. So it is difficult that far out, and that's why I tell people, it's more of like, keep an eye out. Like maybe you have an event next weekend, okay, well maybe we should think about it, but don't cancel the event 6 or 7 days out. Wait, we're pretty good, 3 days out and closer, we're getting better and better. But that 6-7 days, yeah, I mean, I think AccuWeather has like some 100-day or something. They're just using climatology. They're not even but we do have there's a lot of different models to go out, so we have a blend of it, so we kind of blend them all together. We try to take the best of each one of them and kind of blend it together for the forecast.
Thank you.
Mm-hmm. Yes.
Yes. Where is all this rain, the heavy rain in the Midwest, suddenly coming from? The huge amounts of water, where we're getting 6 inches in an hour of downpour and stuff. Where is that water being accumulated? How is it being accumulated in the atmosphere to create that type of a rainstorm?
Yeah, the setup of every feature is kind of unique depending on the region you're in. For them, a lot of their stuff either comes from the West Coast, or if the wind direction is right, when these fronts move in, I'll try to do it with the mic while talking. When these fronts move in, the winds are coming out of the south. So when these fronts move in, it's actually pulling weather from the Gulf, pushing it all the way up into the Midwest. and bringing kind of that, if it's strong enough, it can bring some of that tropical moisture up there. And, you know, it's different. If you're a Floridian your whole life, you know, you hear, 2 inches of rain in an hour, you're like, that maybe made a puddle on the side of the street. But in most places in the country, you know, they have hard clay, you know, and streets like that, water doesn't go anywhere. For us, we have the aquifer, we have, you know, the limestone, so the rain can filter down very quickly. So it takes a lot more rain and a lot more stuff to produce bad flooding for us. While some areas in the Midwest, Texas, especially the desert Southwest, I mean, they get 2 inches of rain in 3 or 4 hours and they've got mudslides and cars are getting picked up and dragged everywhere. So it's, you know, it's that conception too. You're like, oh my gosh, we get 6-inch hour rainfall rates like every time we get a thunderstorm. I mean, it doesn't last for an hour, but you know, you get those heavy rains every day here. So yeah, it's definitely a little bit more unusual, but it happens. It's just the way their topography works. They just can't handle it like we can handle it.
We're going to take one more question.
Okay.
And then Elliot's got a couple of announcements, and then we're going to chow down.
Yeah.
Ocean level rising, speak to that any?
Yeah, it's definitely happening. You know, we're seeing, if you guys are familiar with what's called a king tide, a king tide is a higher than normal tide. It's a natural phenomenon. You know, when a full moon happens at the right time with the high tide, king tides happen. Well, in Miami, those king tides are now flooding streets that never got flooded before. It's happening at Anna Maria Island. You know, those king tides are bringing water up from, you know, where it drains. You know, you got the drains, and it's actually pushing water into the drains. And so we are seeing it, and it is causing those problems. You know, I just talked to the lifeguards in Clearwater Beach 2 weeks ago, and they're talking about how the beach is getting affected because those king tides are being pushed further up, and it's taking a lot of the sand out. And they're already talking about having to put more sand in where they just did it 2 years ago for Milton. And it wasn't because there was a huge hurricane. It's just because, you know, our tides are rising, those king tides are affecting, it's pushing that sand back out again, and they're having to refill it and try to continue to do it. So it is a thing. It's really affecting our weather. It's affecting storm surge more, you know, when hurricanes come, because now we've got more water to deal with. So yeah, it's happening, and yeah, it's definitely rising. It's slowly, but we can already see effects from it.
All right, everybody, help me thank Steve Shiveley.
Thank you.
I have a gift for you.
Okay.
The coveted men's club pen. I say coveted because it's a limited edition now.
Okay.
When supplies run out, we're going to do something else. But
nice.
There's a flash drive at the top of this. Not that anybody uses those anymore.
Yeah, right.
But there you are, my friend, and I thank you. Stick around for lunch. I hear we're about ready.